Chapter 3.6, a summary of curve sketching day 1. We have been doing lots of stuff leading up to curve sketching. We've been using the first derivative test to see when we're increasing, decreasing. We've been using the second derivative test to check concavity. In pre-calc, we've done x-intercepts, y-intercepts, asymptotes. We're going to put it all together to do some curve sketching now. So just in summary, we've done x-intercepts, y-intercepts, domain and range, continuity, asymptotes, differentiability, extrema, concavity, inflection, and asymptotes again. We're going to put it all together. We're going to do some curve sketching. All right, so some main ideas, what we need to do, guidelines for analyzing the graph of a function or doing the curve sketching. First thing you want to do is determine the domain and range. What makes the bottom 0 be your domain? If it's a radical, you can't have 0, anything less than 0 under the radical. So you're going to determine your domain and range. Next, take a look at intercepts and asymptotes. For asymptotes, you're looking at infinite limits or limits at infinity. And then finally, the third thing you're going to look at, your critical numbers, your relative extrema, and your points of inflection. Or in other words, you're going to make a sign chart. You do your first derivative test to see increasing, decreasing. You're going to do your second derivative test to see concave up, concave down, as well as relative extrema and points of inflection. Now, for the AP exam, when you do it in May, most of the time they're going to build this for you, this sign chart, because it can get some pretty hefty algebra for building this sign chart. So I have built the sign charts for you when we do this, and we'll evaluate them. So first off, analyze the graph of f of x equals 2 times the quantity x squared minus 9 over x squared minus 4. We're going to look at some asymptotes. What makes the bottom 0 is negative 2 and 2, so those are some vertical asymptotes. We'll let x approach infinity. That will be horizontal asymptotes, and as x approaches infinity, we got horizontal asymptotes at 2. All right, we'll take our derivatives. And again, these I've worked out ahead of time. F prime is 20x over x squared minus 4 squared. Very important here, you simplify it because you're taking the second derivative. And our second derivative is negative 20 times 3x squared plus 4 over x squared minus 4. And again, you want to use your critical numbers. For the derivative, our critical numbers are 0, and then plus or minus 2, which also happen to be our vertical asymptotes. And then for our second derivative, there's no new critical numbers, so you don't need to list anything else. Then we'll go ahead, we'll make ourselves our sign chart. All right. For our sign chart, our critical numbers, negative 2, 0, and 2, should evaluate the function at the critical numbers. The only one where we need to worry is 0. For the first derivative, we get our signs. It's negative between negative infinity and negative 2. It's negative between negative 2 and 0. Between 0 and 2, the first derivative is positive, and beyond 2, the first derivative is positive as well. We can see that right here, we have a relative minimum because the first derivative changes from negative to positive. We'll do our sign chart for our second derivative. You can see it is negative outside of the asymptotes. Less than negative 2, greater than 2 is concave down. Between negative 2 and 0, it is concave up because the second derivative is positive. All right, So let's go ahead and sketch this now. I'm going to do a split screen so we can kind of look at this. So we built our sign chart. We found our asymptotes. We found our intercepts. We built our sign chart. All right, I'm going to start by plotting the critical numbers. All right, for the asymptotes, we need to plot those at -2 and 2. All right, we have a horizontal asymptote at 2 because x approaches infinity, f approaches 2. And at 0, 18/4, there is a relative min because it changes, the first derivative changes from negative to positive, so at 0, 18/4. So 0, 18/4, 18/4 is the same as 9/2, which is 4.5. All right, so that's the critical information. Now, as we take a look at this, between -infinity and -2, what's happening? Well, the second derivative is negative. That means it's concave down like a frown. The first derivative is negative, so that means it's decreasing. If I take a look at the concave down shape, the part that's decreasing is right here. All right, so as I sketch it, I need to take a look and I need to see, all right, I need to sketch a shape that looks like the concave down decreasing part in the region between -infinity and -2. Something I forgot to sketch for my x-intercepts. I take a look at my original function, what makes the top 0 are 3 and -3. So I'll sketch those. And I can see I need to make the concave down decreasing shape through that x-intercept, remembering the asymptotes. So that's the shape in that interval. Now the next interval, you can see we have a relative minimum at 0. We're decreasing before it, increasing after it, concave up the whole time. Concave up. There's a relative min, decreasing before, increasing afterwards. Remembering the asymptotes. That's the shape in that interval. Now the last interval, it is concave down like a frown. There's my concave down shape. It is increasing because the first derivative is positive. The concave down part that is increasing is this portion right here. So I need to draw that portion in the last interval, making sure I remember my asymptotes and intercept. And right there, that is my graph. Let's take a look at another example. All right, analyze this graph. Again, we want to try and remember our intercepts. I forgot that on the last one. So for what makes the top 0 on that graph, there is nothing that makes the top 0. I used a quick quadratic program on the graphing calculator. There's nothing that makes the top 0, so there's no x-intercepts. The y-intercepts are -2. Find the y-intercepts simply by looking at that. Our horizontal asymptotes let x approach infinity, and because the degree of the top is higher, there is no horizontal asymptotes. because it approaches infinity. So now we need our derivatives, our first and second derivatives. X squared minus 4x over x minus 2 squared, and 8 over x minus 2 squared. You should see that your vertical asymptotes are at x equals 2. All right, we got our y-intercept of -2. Our critical numbers, from the first one, our bottom is 0 when x equals 2. Our top is 0 when x equals 0 or 4. There's no new critical numbers from the second one. So we make our sign chart. All right, so as we take a look, we should evaluate our function at our critical numbers. We can't evaluate it at 2 because that's an asymptote. But at x equals 0, our function becomes -2. At x equals 4, we got 4 squared. Minus 2 times 4 is 8 plus 4. 12 over 2 is 6. All right, and then the rest you can see on the chart. So let's go ahead and apply this to a graph. All right, we will sketch our asymptotes. Vertical asymptote at x equals 2. No horizontal asymptote. There's a y-intercept at -2. There is no x-intercept. All right, and we can see right here using this information at x equals 0, -2 is a relative max because it is increasing before and decreasing after. The first derivative changes sign from positive to negative. And it's concave down, which should make sense for that shape. Remembering our asymptotes, that's the shape we should have in that region. If we look at this interval right here, we should see that x equals 4 is a relative minimum because the first derivative changes from negative to positive, meaning the function changes from decreasing to increasing. And we're concave up. So at 4, 6, remembering our asymptotes and intercepts, that is the shape we get. So to review, guidelines for graphing a function. Determine domain and range. Use that by looking at the top and bottom. What makes the bottom 0 will get you your asymptotes that is tied to the domain. Determine the intercepts and asymptotes. What makes the top 0 is your x-intercepts. Plug in 0 for x to find your y-intercepts. Limits at infinity and approaching and infinite limits are your asymptotes. And then finally, all this wording, you can sum it up, make a sign chart. Look for increasing, decreasing, concave up, concave down, inflection points, and extrema.